Today we're going to look at how to solve Newton's law problems that involve calculating friction using the coefficient of friction. The same basic layout, drawing a free body diagram, identifying all the forces that you know immediately, and leaving any unknowns for later calculation. So let's start out with this one. We have an 1100 kilogram car traveling down the road, assume it horizontal. The force of the engine produces 4,000 newtons. If the coefficient of friction between the car and the road is 0.2, determine the car's acceleration rate. Which means start out by drawing a free body diagram. So I'm going to start out with something fairly simple here. There's my car. I'm going to put the mass inside the block here, and I know it's moving to the right, but remember, force diagrams don't show motion, they show the size and direction of the forces acting on the object. It is on the road, so I'm going to show the fact that because this car is on Earth, we have a gravitational pull down equivalent to the mass times the gravitational field strength, so 11,000 newtons down is the pull of the Earth, and the force of the road pushing up on the bottom of the car or the car's tires is referred to as the normal force, and these are going to be balanced because the car is not moving up or down, so 11,000 up, 11,000 down. I'm going to assume that the engine force is directing the car to move to the right, so 4,000 newtons here, and I do not know the frictional force immediately. I do know we do have one, and I do know that I have a coefficient of friction, which I'm going to use to calculate the friction. So my free body diagram is fairly complete here without doing any massive number crunching. So the only thing I'm really after is once I get this frictional force, I'll know all the forces acting in the horizontal direction. Since the forces in the vertical direction balance, I'm not going to even look at these as far as determining a net force or net acceleration. It is moving only in the horizontal direction, if at all. So the net force I'm looking at is just the addition of these two vectors. We will calculate what the force of friction is and then determine the acceleration produced when these two forces are combined and added together as they act on the car. So calculating the force of friction, we have the coefficient of friction multiplied by the normal force. Coefficient is 0.2. My normal force is 11,000 newtons. Okay, so this is only 2/10 of that, so 2,200 newtons. And just because I want to make sure, because I always, quote, encourage my students to use their calculators and not do things in their head, I want to make sure I'm good there. So that's the size of the frictional force. Most of the force equations we use have direction built into them due to the nature of the way the vectors act. Friction is a force that opposes the direction of motion. So this really isn't a vector equation because if you pull this thing to the right, friction will oppose to the left, which means you have to add the minus sign in there. If you get this thing going to the left, friction will oppose to the right. So this equation intrinsically can't have a positive or negative on it. This is just, hey, this is the size of the force of friction. So it's almost like you're saying this, the absolute value of that number. Now that we have all the forces in the horizontal direction figured out, now we can determine the acceleration of the car. So the net force is the sum of the forces in the x direction that I'm looking at. So we have a frictional force and we have an engine force. Now we bring in the numbers. The frictional force was 2,200 newtons to the left. The engine force is 4,000 newtons to the right. Oh, that's going to act on 1,100 kilograms of mass. So now we have 1,800 newtons surplus, or just the net of those two, divided by 1,100 kilograms. If you can keep in mind that 1 Newton has been defined as a 1 kilogram mass accelerating at 1 meter per second squared. So if you divide a Newton by a kilogram, you get an acceleration rate. So this is going to come back out to be 1.64 newtons per kg, which means 1.64 meters per second squared. And that is how you would solve a multi-force problem involving coefficient of friction and determining acceleration based on that. Free body diagram, friction equation being only magnitude, not direction. You have to decide that. And plugging in the numbers to determine acceleration. That covers today's lesson. Thanks. That's my bubba wave.